Okay. So then we have the same sort of thing for inverse cosine, and I'm not going to do all 6 of these. I really am going to do kind of sine and cosine so that you get the idea of what's happening. So let's do arc cosine, that function. And again, I'm going to just draw it so we can see it's the same sort of idea. I know from the beginning that cosine is not going to be 1-to-1, but I'm just thinking about where, like what the restriction needs to be. So cosine looks like this, and at 0 it's 1, and then pi over 2 is 0, and then I have -1, and it looks like this. So then down here kind of goes like this, right? Okay. It keeps going. This is going to dip down and keep going. And it's 2 pi periodic as well for the fundamental period. And again, you sort of see here that it's not 1-to-1, but and let me say, like, maybe you think I could just define it the same as pi, like minus pi over 2 to pi over 2, but you see here, even that piece of the function, of cosine function, is not 1-to-1. So I can't use, like, that would be a very lovely and amazing, like, coincidence, maybe, that I could just restrict the domain in the same way, but I can't. So, but you do see that if I start here at 0 and just go down to pi, I sweep the full extent of the range of cosine, and then this red portion of the graph is 1-to-1. So this is the restriction for cosine, right? So I'm going to define this function. So define some function y is equal to arc cosine of x. And that's the same thing as x is equal to cosine of y, as long as x is between -1 and 1, and y is between 0 and pi. So again, we see this on the unit circle, and people think about this. So I have this idea of the sine piece on this right half. So this is arc sine, where arc sine spits values out, the output range. And then cosine here, arc cosine, is the top piece. Okay, and so again, when I go to compute these values, so for example, like we'll do, when I want to find cosine, arc cosine, of, let's say, 0, right? And again, I'm thinking of this, that this is equal to some output y, and this is the same thing as if I do cosine of y and solve this equation, which I assume that you have solved before, right? So cosine of y is equal to 0. I'm just like looking for all of the angle values where cosine is 0. And if I just think about solving this, cosine should be 0 up here and also down here in the, from 0 to 2 pi. But again, this top value right here at y is equal to pi over 2 is the one that's in the acceptable output range, that is in this range right here. Like, I'm picking that value right there. That's the value where this function should spit out and is the only value, like defined value for arc cosine of y. Again, this equation here has a lot of solutions, but when I'm really trying, like kind of using it as a tool to find the arc cosine, then it has one solution, right? So these are equal only if, again, like -1 is less than or equal to this like input value. And if 0 is less than or equal to y is less than or equal to pi. So these two are equivalent only within those domains and ranges. And so I can't do anything else. Okay. And again, let's do another one maybe. Problem 2. How about arc cosine of -√2 over 2? And again, I'm thinking of this as going to this equation and thinking, okay, this is arc cosine of -√2 over 2. That means I'm looking for a y value that is negative, that gives this as the output for cosine. And so I'm thinking of this on the unit circle. I need this to be negative and I need it to be cosine. So I need to spit out values in here. Cosine is negative on this, in this like top right quadrant over here. And I know square root of 2 over 2 happens at the pi over 4. So I have like 1 pi over 4, 2, and this should be 3 pi over 4, right? So arc cosine of negative square root of 2 over 2 should be 3 pi over 4. Again, this value has to be between 0 and pi to be a legitimate output for arc cosine. Okay? Okay. And again, we sort of still have these same things that happened before when I compose functions. So, like, again, I have these two identities that cosine inverse of cosine of x is equal to x as long as the original input is between 0 and pi. And then cosine of cosine inverse of x is equal to x when this original input is in the allowed kind of input range of the arc cosine. So again, for example, and maybe we'll do like an example here. Let's say, so for example, let's say I have cosine of cosine inverse, or cosine of, maybe I'll stick with arc cosine. Of let's do, how about 1/2? And I want to know what this is. And honestly, I don't really even have to think about this. Going in this direction, this direction is unproblematic. In the sense that, like, whatever, I could find this angle, the angle that's in the range of arc cosine, and plug it in, but I know that the cosine here will still be the same as this guy, right? It's this one here where you have to be careful because you can routinely have inputs here, angles that are outside the acceptable range for the arc cosine. So there's one example. Problem 2, let's do arc cosine of, let's say, cosine of pi over 12. And again, I'm just thinking of this and going to map it out. But pi over 12, again, is on the unit circle, but it's not one of my standard values, but it's somewhere down here. So right there, and my main question is it in the acceptable range for our cosine? And the answer is yes. So it's fine for the answer here to be just pi over 12. Okay. But for example, if I do another example, arc cosine of, let's say, cosine of negative 2 pi over 3, right? Negative 2 pi over 3 for sure is not between. I'm looking for an output value that's between 0 and pi, right? So I'm thinking negative 2 pi over 3. So here, again, this is pi over 3. This is 2 pi over 3, right? If I go in the negative direction, I'm going to start here and go count back. There's minus pi over 3. And here is minus 2 pi over 3, right? So I'm there on the unit circle. This value for sure is not between 0 and 2 pi, or 0 and pi. But again, I'm thinking about the cosine value here, right? So I'm thinking here about this value of the triangle, this one right here, and making it match. And the one that would have the same cosine value is up here. Do you see that? How these have the same base of the triangle? And so this value, 2 pi over 3, should be the value that this expression should spit out. And you can kind of find this, like if you found cosine of negative 2 pi over 3, right? That should be, let's see, what should it be? Negative 1/2, right? And then you're finding arc cosine of negative 1/2, and that is this guy right here. But really, I'm just sort of thinking about these triangles where it's mapping on the unit circle. Okay. Okay, so then maybe I don't want to go through as many for like tangent, secant, cosecant, but I will say there is this just basic kind of memory tool where you have kind of unsurprisingly tangent is also defined over here more or less. Like there, some of these, like here's the range for arcsine, for arctan, and for arcsecant. And up here is the range for arccosine, arccotangent, and arccosecant. Okay, so people have a memory device to remember these trig functions, and then after that, the reasoning is very similar. So for example, on this side, you have arcsine, arctangent, and cosecant. And then up on this half, you have all of the things related to cosine. So arccosine, arccotangent, and arcsecant. Again, because arctan is like, or tan is defined as like sine over cosine. So this guy kind of has precedence here, and then this one is 1 over sine. So you get kind of this connection with this fundamental equation, and the same thing for arccosine. And again, some of these, like, if for those of you familiar, like arctan, the restriction, like tangent isn't defined at these endpoints here, right? So at minus pi over 2 and pi over 2, it's not defined. So really, we restrict the domain. There's a slight difference here. Like the domain has to be restricted to be strictly between minus pi over 2 and pi over 2. But but we're just going to use this a little bit. I want you to be a little bit familiar with these functions so that you can use them and think about them. But most of our class will be focused on derivatives.